This is Unit 1, Lesson 1, Integers, Opposites, and Absolute Value. Don't forget to take notes on your note sheet. You should have received that in class today, but if you don't have it for some reason, we have blank versions available on Blackboard. So follow along on the note sheet and take notes as though you would normally in a classroom. So consider this, just like anything else, numbers can be classified into different groups. Okay. The numbers that we're going to use in middle school math are all part of the real number system, and within that there's some various subgroups. Real numbers are divided into two main categories, the rational numbers and the irrational numbers. Some of the subcategories are the natural numbers. Those are the counting numbers that were used to count various objects. The whole numbers are simply all the natural numbers plus 0 as well. And integers are the whole numbers and their opposites. The rational numbers are all the numbers that can be expressed as a fraction. So that means all the integers, because an integer such as -5 can be expressed as a fraction, -5/1. All the fractions, 1/4, 7 3/8, any fractional number, all terminating decimals, and all repeating decimals. We're going to talk a little bit more about terminating decimals and repeating decimals in the next lesson. The irrational numbers are all the numbers that can't be expressed as a fraction. Some examples of those are the square root of 5, pi, and this long number that continues forever. So these are all non-terminating, that means they don't end, non-repeating decimals. Now, we're not going to be working with irrational numbers in this unit. The real number system is all the rational numbers and all the irrational numbers. And again, we're not going to be working with the irrational numbers in this unit, just the rational numbers. All right, so back to integers. We talked about them as the set of numbers containing all the whole numbers and their opposites. And you can see that we can show them on a number line with the origin 0 separating the positive numbers and the negative numbers. If we move to the right on the number line, the numbers keep getting greater, and if we move to the left on the number line, the numbers keep getting lesser. So when we're putting them in order, remember that if a number is farther to the right of another number, then it is greater than that number. Now I'm going to talk a little bit about inequality symbols in a little video in a video. Before we proceed, I want to talk a little bit about what an inequality is and how to think about an inequality properly. It's possible that you learned something about inequalities in your past that has to do with an alligator. And if that's the case, I want you to put that right out of your mind forever, because the alligator situation can help you properly place an inequality symbol in between two numbers, but it doesn't do anything in terms of building your comprehension of what an inequality actually is, or how to deal with it when you have an inequality statement that involves a variable. So what you need to focus on instead is knowing what inequality symbols mean and how to deal with them mathematically. So you need to take a look and see this symbol. When you see it, know that means is less than. And this symbol right here is greater than. That one is less than or equal to, is greater than or equal to. So you just need to, independent of those being in a situation with numbers, you need to be able to look at those and recognize what they are. It's important to read an inequality statement from left to right. That's going to help you understand the relationship. Read it left to right just like you would a sentence in the English language, or like you would an equation. So this first one right here, 4 is greater than or equal to 9. That's how we would read that. A little bit less intuitive is how to think about this next one, but really, again, reading it left to right helps you out. X is any number less than 6. So you can think to yourself, any number less than 6. Oh, I know some of those, 5, 4, 3, 2. So that helps you understand how to read that sentence left to right. So when comparing integers, I'd like you to write the less than or greater than symbol in the blanks provided to make each sentence true. We're going to do this first example together, example 1. Example 1a, we look at that. Remember, we're supposed to be reading left to right. So we say to ourselves, 5 is what compared to negative 3? Well, it's farther to the right on the number line, so 5 is going to be greater than negative 3. Example 1b, negative 4 compared to negative 8. Reading left to right, negative 4 is farther to the right on the number line than negative 8, and so negative 4 is greater than negative 8. Example 1c, negative 8 is what compared to 2? Well, it's farther to the left, so it's less than 2. All right, this is your chance to try it. So example 2, I'd like you to do the same thing, write the less than or greater than symbol in each blank. At this point, I'd like you to pause the video, do the problems, and then start it again to check your answers. Okay, let's see how you did. Negative 8 is less than 6. Negative 5 is greater than negative 7. And 0 is greater than negative 11. All right, opposite numbers, opposites. Opposite numbers are two numbers that are the same distance from 0 on the number line. So opposite numbers have the same exact digits, but one is positive and the other is negative. Opposite numbers are also called zero pairs because when they're added together, the result is 0. So here are a couple examples. You can see that 2 and negative 2 are opposites, same digit, one's positive, one's negative. When you add them together, they make 0. We're going to talk about various meanings of this dash symbol. The first meaning is probably the most familiar to you, subtraction. When we see the situation in which it's subtraction, we're going to use the word minus to read it. So when we see that dash symbol between two numbers, it's indicating subtraction. We would read that aloud, 7 minus 4. But it also means negative. So when we see it in front of a number like this, that's indicating that it is negative 4. But it also means the opposite. So when we see that same situation, we could read that and think of it as the opposite of 4. So negative 4 or the opposite of 4 really mean the same thing because the opposite of 4, in fact, is negative 4. This is something that I want you to start thinking of. It's going to help us out when we get to integer operations to think of negative and the opposite in the same way. Here's another situation in which we have the opposite of something, and here's we've got the opposite of negative 4. All right, example 3, we're going to write the math statement using words. Now we're going to keep the numbers written as the numbers, but we're going to replace the dash symbol with words, either subtraction, which is minus, negative, or opposite. So example 3, we would read this aloud saying the opposite of negative 12. Example 3b would say negative 6 minus 7. Now don't forget, if you get a little bit behind, just pause the video and finish writing before moving on to the next part and start the video up again. All right, example 4, I'd like you to do these 4 same way we did example 3. So give them a try, pause the video, give them a try, and then start it up again and check your answers. All right, let's see how you did. First one, you could have written negative 5 or the opposite of 5. Either of those answers would be correct. 10 minus 2, the opposite of negative 23. The last one is negative 30 minus negative 3. All right, here's another little video in the video about absolute value.
Absolute value. The absolute value of a number is its distance from another number on a number line. Distance is a measurement that tells you how far you've gone from one point to another. The notation for absolute value is two straight lines, like this. The absolute value of 4 is 4, because 4 is 4 places from 0 on the number line. Negative 4 is also 4 places from 0 on the number line, so its absolute value is also 4. Absolute value is always a positive number because it's the distance from the other number, in this case 0, no matter the direction. Here's Lucy. She needs to walk to her tuba lesson, 3 blocks from the bus stop. After walking 2 blocks, she realizes she dropped her sheet music. She goes back 1 block, finds it, then continues to her lesson. One way to represent Lucy's journey is like this, by walking 2 blocks forward, 1 block back, and 2 blocks forward. Lucy ends up 3 blocks from the stop, yet she walked more than that. Absolute value shows us how much she actually walked. 2 blocks forward, plus 1 block back, plus 2 blocks forward, for a total of 5 blocks. Phew! Absolute value can help us calculate distance and solve math problems.
All right, example 5. I'd like you to do the same thing now. Go ahead and try these. Simplify each expression, computing the absolute value. Go ahead and pause the video and start it up again and check your answers. All right, let's see how you did. The absolute value of -8 is 8. The absolute value of 14 is 14. It's distance of 14 away from 0. Part C, you're going to compute the absolute value of each value first, and then go ahead and add them together to get 8. In D, you'll see that you need to first compute the expression inside the absolute value, so you first need to do 10 minus 4 and get 6, so you've got the absolute value of 6. Then you take its absolute value and get the answer of 6. E, we've got 7 times the absolute value of -3, so the first thing we need to do is take the absolute value of -3, which is equal to 3. So I'm going to write it as 7 times 3, and then I do that computation and get 21. Now, you could probably have done that all in your head, but it's important to communicate what's going on in your head and show those steps so that we can see what your thinking process is. Same with F. First thing we want to do is add 4 plus 3 together to get one number inside the absolute value. So we have 5 times 7. Then we're going to take the absolute value of 7, which is 7. So I'm going to write 5 times just plain 7. And then I'm going to do that computation and get 35. All right, that's it. There will be a quick quiz tomorrow at the start of class. You may use the note sheet that you've just completed during the quick quiz. So put it in your binder right now. Make sure you bring your binder to class so you can have it with you to help you out during the quick quiz.